Good afternoon, my YouTube viewers. In this particular video, we're going to be using the normal distribution to calculate the heights of adult men. And so the practice problem that we have is you are analyzing the heights of adult men in a population. The mean is 175 centimeters and the standard deviation is 10 centimeters. Find the cumulative probability that a randomly selected male is greater than 190 centimeters. And that's going to be your survival function as well. And so the first thing that we want to do is we want to import the library that we're going to be using to execute the program. So from scipy.stats, we're going to import norm. Scipy is Python's scientific library, and stats is a statistical module within Scipy, and norm is the function that we're going to be using. So we're going to be setting the parameters of the normal distribution. So mean is 175 centimeters, standard deviation is 10 centimeters. The height threshold in this instance is 190 centimeters. And that is your survival function. Okay, so we're going to calculate the probability of being greater than the threshold. So probability greater equals 1 minus norm dot CDF. And it's going to be threshold is 190. Log is mean of 175 and scale is standard deviation. But what I want to do is I want to say and then so what we're going to do is we're going to print and then what we're going to do is we're going to calculate the probability of being greater than the threshold. So I've already talked to you about the 1 minus norm.cdf. That's cumulative distribution function. But 1 minus norm CDF is pretty much the same as the survival function. So, and then so we're going to print these two probabilities. So I'm going to go ahead and run it. And then so it gives you the same answer, the probability greater and the probability greater is SF gives you the same answer. So you get the same answer with 1 minus norm.cdf that you get with the .sf. So that's just what I wanted to prove, that you can do it either way. You can do it 1 minus norm.cdf or you can do it with SF. And one thing that I will say is that, like, if you decide to calculate these probabilities in Excel, I think you would have to use the CDF, 1 minus CDF, because I don't think that Excel has the survival function, but I can't guarantee that. But I think that when I was working with Excel, I personally didn't see a survival function. But that doesn't mean it's not there. It just means I personally didn't see it. So now we're going to go to the next question. And that's exactly, I'm just going to go ahead and delete this one. And the reason why, because I put both the survival function and the 1 minus CDF in the one cell just for that purpose. Now we're going to ask another question. What is the cumulative probability that a randomly selected male is taller than 180 centimeters? And again, that's also a survival function. So from scipy.stats, we're going to import norm. So scipy is Python scientific library. Stats is a statistical module within scipy. And norm is a normal distribution that you're going to use to calculate these values. So the mean is 175 centimeters. The deviation is 10 centimeters. And the threshold is 180 centimeters. Okay, so we're going to calculate the probability of being taller than the threshold. So probability greater equals 1 minus norm CDF, that's cumulative distribution function, brackets threshold, comma, log equals mean of 175, comma, scale equals standard deviation. So what I just want to do is I want to say so this is so basically what we're going to do is we're going to calculate the survival function in the same cell because I believe they're going to give you the same values. So probability greater SF equals norm.SF threshold, brackets threshold, comma, log equals mean, comma, scale equals standard deviation. So we're going to come over here. So I'm going to run it again. And then so basically the survival function is 30.85%. It's the same as the 1 minus CDF, cumulative distribution function. So that's just telling you that the survival function and the 1 minus CDF are the same. And so you can use either the 1 minus norm CDF or you can use the survival function. So I'm just going to delete this because we've already done it. We've already done that. So now the next question is, what is the probability that a randomly selected male is shorter than 160 centimeters? So from scipy.stats, we're going to import norm. Then we're going to set our parameters. Its mean is 175 centimeters. Standard deviation is 10 centimeters. The height threshold is 160. So you're looking for something shorter than 160. So you're going to calculate the probability of being shorter than the threshold. So probability shorter equals norm.cdf, brackets threshold, comma, log equals mean of 175, comma, scale equals standard deviation of 10. And then so we print the probability that a randomly selected male is shorter than the threshold, CM, is approximately probability shorter. So we come up with the answer to that, and the probability of a male shorter than 160 centimeters is 0.0668. Now, I used to be 165 centimeters, so 165 centimeters is around 5'5", but I'm not 165 centimeters anymore because I've gotten older. But so 160 centimeters is like maybe 5'2" or something like that. So the probability of a male being 5'2" is 0.0668. So that concludes this video where we talk about the probability of male heights. The next video is going to be a manufacturing question, and I hope that you decide to watch it.